All right, here we go. Let's finish up our notes from yesterday, and then, like I said, you're gonna work. Yeah, you have a test on Thursday. I don't know how we don't know that in here. All right. So yesterday, and then like on Friday, we introduced this idea of the mole. So it's how a chemist is going to count how many atoms are in a sample, just like a baker counts by the dozen. Chemists count by the mole. Okay. So yesterday you learned your two relationships you've got to get down. All right. So you have two big equalities in this unit that you need to know. And the first one was that atoms, so that's one of your units, relates to moles. So these two relate. There's a spot on your notes for like this on the front page in a little box.
Is it called Rhoda?
Yeah. Atoms and moles relate to each other. And that was the first thing we learned about yesterday, right? That the word mole just means a very specific number to a chemist, right? So mole is how we kind of group atoms, just like bakers group their donuts by the dozen, we group our atoms by the mole. Right? And so your relationship here, we always use Avogadro's number for this conversion. And we know that 1 mole of any element is 6.022 times 10 to the 23rd atoms of that element. And so that was our first relationship we talked about. That you have to understand that the word mole is just a grouping of a certain number of atoms. Remember, you can have like 2 moles, you can have half a mole, just like you can have 2 dozen, you can have half a dozen. And honestly, with moles, you can have tiny little fractions of it because it's such a large number. Okay? The second relationship you need to know is that moles also relate to grams. So moles is kind of your middleman, right? It's the in-between unit for grams and atoms. For that relationship, we always look on the periodic table. And specifically, it's the decimal number. It's your average atomic mass that we're going to use. Okay? And we do this because unlike a baker, where when they count out your donuts at the donut shop, right, they can very easily put them in the box in a 4x3 pattern and keep track of how many you have. A little harder to keep track of counting atoms, so we want to relate it to something we can measure in the lab. All right, so we need to relate our counting unit to something that we can measure in the lab. You can't measure moles in the lab, you can't measure atoms in the lab, but we can very easily measure the mass of our sample. All right, so we needed a way to relate it, this counting term, to something we can measure. And again, in the video we watched on Friday, it's the same idea of when you go to the deli counter, you don't typically order like by the slice, you say I want this many pounds because you know about how many slices you're gonna get, right? We're going to use mass to count how many atoms are there. And so your relationship, your other one to know, is that 1 mole of any element is your periodic table number of grams for that element. And we talked Friday, it should make sense that they have different masses, just like a dozen paper clips had a different mass than a dozen keys, right? A mole of one element is going to have a different mass than a mole of another element because they are different sizes. Now, my children who are very excellent at math are probably looking at this and going, well, couldn't I just go straight from atoms to grams, right? And just say that 6.022 times 10 to the 23rd atoms equals the periodic table grams, right? I know some of us are like, I could do this much faster. Please don't. At the end of the day, moles is the unit we relate everything to in chemistry, right? So mole becomes our central unit for everything we do. So please don't bypass the mole in these relationships. Please relate atoms to moles and then moles to grams. Right? Don't skip it, is what I'm saying, because we are going to do lots of things with the mole throughout the whole year. Okay? So we'll do 2 examples, and then your group can decide if you want to do the other 2 that are in the notes, or if you just want to go straight to your CYU set. You all can decide. So we'll do 2 together, combining. I think most of you in year can figure out like what to do, but that way it's officially in our notes. You've got examples to look back at. So it says, what is the mass in grams? So there's your unit we're looking for. We want grams. I mean, generically, your units are grams, moles, atoms. But those are the three. So determine the mass in grams of 5.0 times 10 to the 22nd atoms of neon. Underline the number you've got to start with, just good problem solving techniques to keep track of what you've got. Write down the number we have in the beginning. So 5.0 times 10 to the 22nd, include the unit. Those are atoms. That was the measurement. That's how many atoms are there. And then please get in the habit of including the symbols. What's the symbol for neon? Ne. And then we learned dimensional analysis last unit, so you could set things up like a chemist does. All right, it's how chemists set up all of their problems. All right, so again, whatever unit's on the top, where do we automatically have to write it? On the bottom. So atoms of neon have to go on the bottom. Okay? You only know one thing atoms relate to. All right? Atoms relate to moles. That's your only option for a relationship there. So atoms have to relate to moles. And then you have to know what the relationship is. You need to know that 1 mole means you have 6.022 times 10 to the 23rd atoms. Okay? Now, side note, if you're pretty confident that you already know that number, right, and you're already tired of writing it, because I get it, just imagine like every time you're writing it, I write it 4 times as much because I have to write it for every bell that we do this. You can abbreviate that number with an A with a circle for like Avogadro's number, but don't do that until you are confident you know the number. All right, so maybe writing it a few more times will be good for you, but once you're like, oh, I know that a mole is 6.022 times 10 to the 23rd, then you can start shortcutting it, right? Save yourself some time. Or not, that's an option. All right, atoms cancel. Longer than yesterday because our question is grams and we currently only have moles. So we're going to go one more step. On the bottom of the next one, we have to write moles. And then this is where you only know one other thing that moles relate to. You don't want to go backwards. You don't want to go back to atoms. So our only other option for moles is grams. And we look on the periodic table for that. Find neon. It's number 10. Find the decimal number. It's 20.18. That always goes with grams. And I've told you that for now, inside of your conversions, moles gets a 1. Right? That will change one day. But for a little while, we'll stick with it. And then we do our math. Start with the beginning number. I would highly recommend you use the magic E button I taught you yesterday. Divide by 6.022 times 10 to the 23rd. Multiply by 20.18. Again, you can do it all at once. Right, in your calculator, you don't need to stop along the way. And mine gives me 1.67552, blah, 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 blah. Sig figs wise, our starting number has 2 significant figures. Avogadro has 4, our periodic table has 4, so we'll just keep 2 in our answer. So we'll keep 1.7. So what does this mean? This means, okay, neon's a gas, it's in neon lights. So if you had a balloon and it was full of neon gas and it had a mass of 1.7 grams, inside there are 5 times 10 to the 22nd atoms floating around doing their thing. All right, so it's a chemist's way of talking about how many atoms are there by knowing what the mass is. Okay, so that's what it means. I'm trying to make sure you understand like why we do all of this.
Wait, would you take off points for rounding incorrectly?
If you put 1.6?
Or like 1 point, or like extra numbers?
Extra numbers, yes, because that would be sig figs.
Okay.
But if you put 1.6, no. Like if your last number and my last number are different and they're close, I don't care. But I do always grade for sig figs. Half a point every single time.
So you just look at like the 5-point videos?
Yeah, generally like 95% of the time this number will tell you. Alright, second example, and then like I said, you can practice with your friends. So it says, how many atoms? So I always box what I'm looking for. I like to write it down. I want atoms at the end of this of carbon are in 0.020 grams. There's our starting number of carbon. Write down your starting number with the unit and the symbol. So grams of carbon. Right, so this is like a speck of your pencil lead. So if you had the tiniest little piece of pencil lead would be 0.02 grams, and then you can tell me how many atoms would have to be inside your sample. Okay. Grams are on the top. Where do they have to go? On the bottom. Right, grams does have a lot of relationships you could make, but since our ultimate goal is atoms, right? If you want to write little like thought processes again, that's fine. All right, to get to atoms, you have to go to moles. Right, that's the only way to get to atoms is through moles. So we're going to turn our grams into moles. Grams, periodic table. Find carbon. Decimal number, 12.01. So 12.01 grams. And then I've said again and again that for now, moles gets a 1, so put a 1. Grams. And then we don't want moles, we want to go one more step. Moles on top, so moles on the bottom. Moles relate to atoms. And then again, you have to know this relationship. You have to get Avogadro's number down. So 1 mole is 6.022 times 10 to the 23rd. And if you already know it, put the A with the circle, that is fine. And then we got our calculators. 0.02 divided by 12.01 times Avogadro. I got 1.0028 blah 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 times 10 to the 21st. Remember, atoms should always be a really big number, but never should anything be 10 to the 40 something. We can keep 2. So 1.0 times 10 to the 21st atoms of carbon. So again, if you had a tiny little speck of pencil lead, like as you're writing right now, just imagine the tiny little speck that you just put on your paper to draw a dot. That's probably about 0.02 grams. In that little dot, there's 1 times 10 to the 21st atoms of carbon on your paper right now, if you're writing in pencil. And that's kind of what you're doing here, talking about how many are there. All right, questions? Yeah.
For the answer, do you have to write 1.0 times 10 to the 21st, or can you write the E?
The E is a calculator function, not the math way. So times 10 to the 21st. I think your math teachers would be a little upset with me